And it's ready whenever you are, Asko.
Okay. I thank Greg Jamieson for inviting me to participate in this interesting panel. Distinction of graphemes and allographs is of great importance for the structural analysis of the Indus inscriptions. This is the main problem in the construction of a sign list and the topic of this paper. Data processing has made it possible to analyze the Indus inscriptions much more easily and more effectively than in olden times, when the very first sign lists and concordances were compiled by hand. Such a pioneering list of early Indus script by two Assyriologists, C.J. Gadd and Sidney Smith, was published in 1931 in Marshall's report on the excavations of Mohenjo-daro. The first computer-compiled and computer-drawn concordance and sign list comprising 395 signs, based on all the then available Indus inscriptions, 3,191 in all, was published by the Finnish team of Seppo Koskeniemi, Asko Parpola, and Simo Parpola in 1973. The computer-controlled plotting of the concordance was a complicated and lengthy operation. Every single page was drawn with an India ink pen on a paper page sized 48 by 64 centimeters. It took about half an hour for each page, and many pages had to be redrawn because the pen either dried up or overflowed. Before this, yours truly had to define the shape of each of the 400 different signs for the plotter's pen with a great number of X and Y coordinates. Airavata Mahadevan's book, The Indus Script, in 1977 contains an improved concordance along with the input texts and a sign list of 400 signs with graphic variants. The Indus Research Center at the Roja Mutaya Research Library in Chennai has in 2021 made a searchable web application of Mahadevan's work available in the internet. Kimmo Koskeniemi and Asko Parpola published in 1979-1982 a revised edition of the Indus texts and a new concordance based on it, with a sign list of 403 signs Asko Parpola published a sign list of 398 signs with allographs in his book Deciphering the Indus Script in 1994. Brian Welles's Harvard PhD of 2006, entitled Epigraphic Approaches to Indus Writing, was published in 2011. It contains, among many other topics that cannot be discussed here, a sign list of 709 signs. This is almost twice the about 400 different signs recognized by Mahadevan 1977, and Parpola 1994. Each of the signs is catalogued with information on the respective sign class. That means compound, sign, complex, marked, or simple. Total and positional frequencies, terminal, medial, initial, solo. Frequencies of occurrence at different sites and inscription type, as well as the accompanying iconographic motifs. Andreas Fuls, a German mathematician studying ancient writing systems, joined Wells in 2008, and the two created an online epigraphic database called Interactive Corpus of Indus Texts. Fuls developed new mathematical methods and tools to analyze the statistical and positional behavior of Indus signs, to map the spatial distributions of signs and inscribed artifacts, and to define sets of signs with similar positional behavior. In 2015, Wells published a booklet called The Archaeology and Epigraphy of Indus Writing, with technical appendices by Andreas Fuls. This is a summary and further development of his thesis, including the sign list of 709 signs, which Wells defends with some arguments that I shall take up in a moment. In 2022, Fuls published Corpus of Indus Inscriptions, containing 4,660 inscribed artifacts from 73 sites, arranged in alphabetical order. These are published in computer-created Indus characters with the corresponding sign list numbers beneath them, along with the interactive corpus of Indus texts, number, and so on. Here we focus on the sign list, which is based on the previous epigraphic analysis by Wells and contains 709 different signs. In 2023, this year, Fuls published a catalogue of Indus signs, which contains a wealth of useful new information besides the list of 713 different signs arranged in 71 sets of graphically similar signs. These sets come from Wells, who refers to them in his 2011 sign list. Each of the signs is catalogued with information on the respective sign class and set, total and positional frequencies, frequencies of occurrence at different sites, frequencies of occurrence in the different artifact types, a positional histogram, and an exhaustive list of all texts where the sign occurs. These catalogues of Wells and Fuls are valuable new tools of research, but the graphemic analysis is, in my opinion, widely mistaken and leads to erroneous analyses. In 1994, I wrote, in a distributional analysis, false conflation of two graphemes into one is as detrimental as false distinction of two allographs. The analyst must take both possibilities into account with equal care and search for optimal solutions. I have suggested the following criteria for identifying two or more graphs as variants of a single grapheme. 1. The potential variants bear a reasonable resemblance to each other, so that they can be assumed to represent one and the same object. The likelihood of their being identical is increased if intermediate forms establish a continuum between the variants. Two signs meeting the above condition occur in almost identical contexts. Allographs may have a complementary distribution among different types of object. That means one may not appear in the same situations as the other. 3, if there are any ligatures, that means composite signs, composed of the same signs, they may behave in the same way as the simple signs. Application of the context criterion can be very convincing if the signs have a high frequency, but when they occur a few times only. The conclusion is bound to remain open to doubt unless the contexts are long and unique. As an example, I took the sign which in my sign list has number 91 and very many graphic variants, resembling more or less each other and forming a continuum of shapes, possibly depicting tree with branches or grain with awns. The principal variants look like a trident and a stem ending in right-turning branch with 2 to 5 left-going short strokes. These occur interchangeably in several contexts, notably in a very common sequence of 3 signs, often occurring at the end of an inscription. These 2 principal variants are also joined with the circle into a ligature, the distribution of which shows that the variants behave as allographs. Wells and Fuls, however, distinguish as separate graphemes the trident and they have as many as 7 of my allographs as separate graphemes. Sign 407 has 3 allographs. The trident variety of the circle ligature is sign 803, while the other variant is signs 805 and 806, the latter said to have 5 allographs, one of which is identical with sign 805. Our conflation of the above signs is criticized by Wells in connection with our conflation of his signs numbers 153 to 158, which we shall discuss now. Wells quotes in extenso Mahadevan's sign list, sign number 15 and sign 4 of my sign list with variant allographs and criticizes them as follows. Some of these signs are obviously separate graphemes. Through the analysis of their contexts, the remaining examples can be grouped into 4 separate graphemes. Sign 156, those with arms and a carrying pole. Sign 155, those with no arms, but which have a carrying pole, and sign 158, those with neither arms nor a carrying pole. The final group are those varieties that are completely unique. Sign 153 is a separate grapheme despite Parpola's list. The signs discussed are all ligatures of the most frequent sign of the Indus script, usually occurring in the final position, and the sign depicting a man with a carrying pole. It is a natural and expected development of a pictographic script that signs get simplified, and one cannot give any other explanation for the allographs. I cannot imagine any different meaning that could be expressed with a simplified allographs. A comment on the unique sign in Mahadevan's list, the last but one. The straight line instead of a pot is likely to be due to incomplete carving. Wells continues. The context most relevant to these signs, 155, 156, and 158, is the sequence that occurs 5 times at Mohenjo-Daro and 17 times at Harappa, with signs 155 and 158 co-varying, and signs 467 to 468 occurring in most cases. Sign 156 never occurs in this context. The most constant element in this sign cluster is the middle sign, 806. Sign 806 is never replaced by sign 803, and therefore signs 806 and 803 are not allographs, as Parpola suggests. Likewise, signs 390 and 407 must be separate graphemes, as their ligature forms are separate graphemes. I do not think that the absence of the said variants from this particular context establishes them as separate graphemes. However, this context is important in proving that the signs 465 and 467 to 475, which Wells distinguishes as 10 separate graphemes, are in fact allographs, as most of them occur in this very context only. This sign with its allographs occur almost exclusively in the 3-sign sequence discussed, which has numerous occurrences in the Indus inscriptions. Here in our concordance, the allographs have all been conflated into one of them. In my sign list, they are number 202 with 13 allographs. One of the most important but also most difficult tasks in the study of the Indus script is to identify the objects represented by the pictograms, the great majority of which do not have an obvious explanation. Here the allographs offer a possibility to see a wider variety of representation that may help in the interpretation. In my opinion, allograph M depicts the basic object represented, practically identical to the representation of Ho in an Egyptian wall painting, and the strokes beneath or beside its head probably represent grass or plants, as seen in the Egyptian painting. The line over these strokes may have resulted from the seal carver's wish to keep the strokes in line. Mahadevan and Parpola have taken the two signs shown here in the margin of the page as allographs, or one grapheme, because they resemble each other and occur very frequently in similar contexts. Wells and Fuls, however, have taken them to be separate graphemes because, according to them, both signs are used in one and the same inscription on a tablet from Harappa. In the photo of that tablet, however, also the sign on the right has a circular edge and not angular edge, at least on the right side. I object to Wells's identifying as one grapheme doubled occurrences of one sign. In many languages, repetition of a word or morpheme can denote plurality, intensification, or some other meaning. In the case of Wells Fuls sign number 552, the two signs taken as one are not identical, but both occur also separately. I close this talk by suggesting what these abstract-looking signs may depict. This sign combination calls to my mind the iconographic representation of bullfight in the tablet from Mohenjo-Daro, 1367. The opposing front parts of the signs could depict horns. The general shape of this and many other signs calls to mind how animals were represented in very early Iranian art, as in this painting on a goblet from Susa A. Sign number 232 in my sign list is distinguished from sign number 231 by the addition of what looks like a tail to the hind part of the sign. This tail may be just a help sign to enable the identification of the sign as a representation of a bovid animal. What do the three strokes above and beneath the sign signify? Could it be the hump and the dewlap of the zebu, or perhaps more hair around the head? Thank you.